Given that n can be any integer, such that n is greater than 1, prove that n squared minus n is never an odd number. So this n squared minus n, what could we do with that? Well, I could factorise an n outside. The n times the n is the n squared. The n times the minus 1 is the minus n. And then I noticed that this n times n minus 1, these two numbers, n and n minus 1, if you can't spot what's important about those yet, it might be helpful if I rewrote that the other way round as n minus 1 multiplied by n. Hopefully you can now spot something about n minus 1 and n. They're consecutive numbers, they're one after the other one. N minus 1 is always going to be in front of n. So these are consecutive numbers. And there's something important about if you have two consecutive numbers. One of those numbers must be an even number. Because if this is odd, then that one has to be even. Or if it was the other way around, if the n is odd, then n minus 1 is even. If you have two consecutive numbers, one of them must always be even. And whenever you multiply a number by an even number, it's always going to be even. And therefore the result can never be odd. So one must be even, and the product of those, the n times n minus 1, must also be even and can never be odd.